In 2020, Nobel Prize winner Sir Roger Penrose published a theory so radical that it makes the multiverse look conservative. He claims our Big Bang wasn't the beginning of everything, but just the latest explosion in an infinite chain of universes that have been cycling for eternity. Each cosmos lives, dies, and gives birth to the next in a cosmic recycling program that has no beginning and no end. But here's what will blow your mind. Penrose doesn't just claim this cycle exists, he says he's found evidence of it hiding in the leftover radiation from our own Big Bang. Circular patterns in the cosmic microwave background that could be the footprints of black holes from the universe that came before us. Tonight, we're diving deep into Penrose's conformal cyclic cosmology, a theory that turns everything we thought we knew about existence upside down. We'll explore how black holes might be the architects of new universes, why infinity isn't just a mathematical concept, but the fundamental nature of reality itself, and what it means if our entire cosmic history is just one chapter in an endless book that keeps writing itself. This isn't just theoretical physics, this is a complete reimagining of what it means to exist in a universe that never truly began and will never truly end. Now, prepare yourselves, we begin. Picture the most violent event imaginable. Every atom in existence compressed into a point smaller than a period at the end of this sentence, then exploding outward with unimaginable fury. We call this the Big Bang, and for decades, scientists have treated it as the ultimate beginning, the moment when time, space, matter, and energy burst into existence from absolute nothingness. But Roger Penrose looked at this cosmic creation story and asked a disturbing question. What if the Big Bang wasn't the beginning at all? What if it was just another event in an infinite sequence of cosmic explosions, each one birthing a new universe from the ashes of the old? This radical idea emerged from Penrose's decades of work on black holes, mathematical physics, and the deepest mysteries of space-time itself. At 89 years old, after winning the Nobel Prize for proving that black holes are inevitable consequences of Einstein's general relativity, Penrose had earned the right to propose theories that sound like science fiction. But conformal cyclic cosmology isn't fiction. It's a mathematically rigorous framework that could revolutionize our understanding of existence itself. The theory starts with a simple observation that leads to mind-bending conclusions. Our universe is expanding and cooling. Stars are burning out. Black holes are slowly evaporating through Hawking radiation. Eventually, in the unimaginably distant future, our cosmos will become a cold, empty, dark place where nothing interesting ever happens again. Most physicists call this the heat death of the universe, the final chapter in cosmic history. But Penrose saw something else entirely. He realized that a universe filled with nothing but massless particles behaves in a very strange way. Time becomes meaningless. Space becomes infinitely stretchable. The mathematical structure of reality itself becomes what physicists call conformally invariant, meaning you can rescale the entire universe without changing its fundamental physics. Here's where it gets weird. If time becomes meaningless in the far future of our universe, then that far future could be mathematically identical to the moment before the Big Bang. The end becomes the beginning. The heat death of one universe becomes the birth cry of the next. Imagine a cosmic phoenix that doesn't just rise from its own ashes, but actually transforms its death into its rebirth through pure mathematical inevitability. This is conformal cyclic cosmology in its most basic form. An infinite sequence of universes, each one emerging from the conformally transformed death of its predecessor. But Penrose didn't stop at elegant mathematics. He made a prediction that could be tested. If his theory is correct, then our universe should contain traces of the universe that came before it. Specifically, the cosmic microwave background radiation, that faint afterglow of our own Big Bang, should contain circular patterns created by the final moments of black holes in the previous universe. These aren't just any circles. They're Hawking points, named after Stephen Hawking's discovery that black holes evaporate by emitting radiation. In the dying moments of the previous universe, as the last supermassive black holes slowly evaporated, they would have released enormous bursts of energy. This energy would carry forward into our universe, creating detectable patterns in the cosmic microwave background. Think of it like cosmic archaeology. We're not just studying the history of our own universe, but potentially uncovering evidence of entire cosmic civilizations that existed before time itself was reset. The circular patterns Penrose claims to have found could be the shadows of black holes that consumed entire galaxies in a universe that died trillions of years ago only to give birth to our own cosmic epoch. The implications are staggering. If Penrose is right, then the question, what came before the Big Bang, has a simple answer: another universe. And before that, another universe. And before that, the pattern continues infinitely in both directions, creating a cosmic history that has no beginning and no end. But this isn't just about the past. Conformal cyclic cosmology makes specific predictions about our future. Our universe will eventually expand and cool until only massless particles remain. The final black holes will evaporate completely through Hawking radiation. Space and time will lose their meaning, creating the perfect conditions for another Big Bang to emerge from the mathematical structure of conformally invariant spacetime. We become part of an infinite chain of cosmic evolution, where each universe builds on the achievements of its predecessors. The complexity that emerges in our cosmos, the galaxies, stars, planets, and perhaps even consciousness itself, doesn't disappear when our universe dies. It gets incorporated into the initial conditions of the next cosmic cycle. This creates a form of cosmic natural selection, where universes that develop interesting physics and complex structures are more likely to spawn successor universes with even richer possibilities. Our universe isn't just expanding into empty space, it's evolving toward its role as the parent of future cosmic epochs. The mathematics behind this theory draws on some of the most advanced concepts in theoretical physics. Conformal geometry, which deals with shapes that can be stretched or compressed without changing their essential mathematical properties. Spinor fields, which describe the fundamental quantum properties of particles and spacetime itself. Twistor theory, Penrose's own mathematical framework for understanding the deep structure of physics. But you don't need to understand the mathematics to grasp the profound implications. If Penrose is correct, then existence itself operates on principles completely different from what we've assumed. Time isn't linear. The universe isn't unique. Reality consists of an infinite succession of cosmic epochs, each one a chapter in a story that never ends because it never truly began. The theory also addresses one of the most puzzling aspects of our universe. Why does it seem so perfectly tuned for complexity and life? The fundamental constants of physics, the masses of particles, the strengths of forces, all seem calibrated with impossible precision to allow stars, planets, and eventually biology to emerge. This fine-tuning problem has puzzled scientists for decades. Conformal cyclic cosmology offers an elegant solution. Our universe isn't fine-tuned by accident or design. It's fine-tuned by evolution across cosmic epochs. Universes that develop interesting physics and complex structures are more likely to give rise to successor universes, creating a natural selection process that operates on the largest possible scale. Over infinite cycles, the cosmos learns how to create better versions of itself. Our universe represents billions or trillions of years of cosmic evolution, where each previous epoch contributed something to the magnificent complexity we observe today. We're not living in a cosmic accident. We're living in a universe that has been refined across infinite iterations of cosmic natural selection. But perhaps the most profound implication concerns consciousness itself. If Penrose is right, then conscious observers like humans aren't just temporary arrangements of atoms that emerged by chance in one particular universe. We're part of a cosmic process that spans infinite epochs, where consciousness might be one of the key features that gets preserved and enhanced across cosmic cycles. This doesn't mean individual consciousness survives cosmic death and rebirth, but it suggests that the capacity for consciousness, the physical and mathematical structures that make awareness possible, could be fundamental features of reality that persist across infinite cosmic generations. We might be living in a universe that has been unconsciously designed by previous universes to support consciousness, complexity, and intelligence. Not through any intentional process, but through the mathematical inevitability of cosmic evolution operating across infinite cycles of death and rebirth. The search for evidence continues. Teams of cosmologists are analyzing the cosmic microwave background with increasing precision, looking for the circular patterns that would confirm Penrose's extraordinary claims. Some claim to have found them. Others dispute the findings. The scientific debate continues with the intensity that only accompanies theories radical enough to change everything. But even if the current evidence remains inconclusive, conformal cyclic cosmology has already achieved something remarkable. It's forced physicists to think beyond the traditional Big Bang model and consider possibilities that seemed impossible just a few decades ago. The theory suggests that our universe is far stranger and more magnificent than we ever imagined. We're not living in a cosmic accident that emerged from nothing and will return to nothing. We're part of an infinite cosmic story that has been unfolding for eternity and will continue unfolding forever. Every star that shines, every galaxy that spins, every moment of consciousness that emerges becomes part of a cosmic inheritance that gets passed forward to future universe. Nothing is truly lost. Everything contributes to the infinite evolution of reality itself. This perspective transforms how we think about our place in the cosmos. We're not insignificant specks in a vast, meaningless universe. We're participants in the greatest story ever told, a tale of cosmic evolution that spans infinite cycles of creation, complexity, and renewal. The mathematics of infinity has always made physicists uncomfortable. Most prefer their equations to produce finite, measurable results. But Penrose embraces infinity as the fundamental architect of reality. In conformal cyclic cosmology, infinity isn't just a mathematical abstraction. It's the engine that drives cosmic evolution across eternal cycles of death and rebirth. Consider what infinity actually means in this context. We're not talking about a very large number or an incomprehensibly long time period. We're talking about genuine mathematical infinity, an infinite sequence of universes stretching backward and forward through cosmic time without beginning or end. Each universe lived, died, and gave birth to its successor through processes that have been operating forever. This creates paradoxes that challenge our basic assumptions about causation and existence. If the cosmic cycle has been operating infinitely, then every possible universe has already existed infinite times. Every arrangement of matter and energy, every possible history, every potential outcome has played out across infinite cosmic epochs. But here's where Penrose's theory becomes even more radical. The infinite repetition doesn't create exact copies. Each cosmic cycle builds on information from previous cycles, creating an evolutionary process that operates across infinite timescales. The universes get more sophisticated, more capable of supporting complexity, more refined in their ability to generate interesting physics. Think of it like an infinite library where each book is written based on all the books that came before it. The early volumes might be simple, but over infinite iterations, the stories become incredibly rich and complex. Our universe might be volume number infinity in a cosmic library that has been writing itself forever. This perspective solves several deep puzzles in cosmology while creating new ones. The horizon problem asks why different regions of our universe have almost identical temperatures despite being too far apart to have ever communicated. Traditional inflation theory requires faster-than-light expansion to solve this puzzle, but conformal cyclic cosmology offers a different solution. The uniformity we observe might be inherited from the previous universe, where different regions had billions of years to reach thermal equilibrium before the cosmic cycle reset. The smoothness of our cosmic microwave background reflects not rapid inflation, but slow equilibration across an entire previous cosmic epoch. The flatness problem questions why our universe has exactly the critical density needed to avoid collapse or runaway expansion. Again, traditional cosmology requires fine-tuning that seems impossibly precise. But if universes evolve across cosmic cycles, then the critical density emerges naturally through cosmic natural selection. Universes with the wrong density don't last long enough to spawn successors. Yet the theory faces formidable challenges that keep most physicists skeptical. The second law of thermodynamics states that entropy always increases over time. How can a universe reach maximum entropy at its heat death, then somehow reset to the low entropy conditions needed for a new Big Bang? Penrose's answer involves the peculiar properties of massless particles and conformal geometry. In the far future, when only photons and other massless particles remain, the concept of scale becomes meaningless. You can stretch or compress space by any factor without changing the physics. This conformal invariance creates a mathematical bridge between the heat death of one universe and the Big Bang of the next. But the mathematics is so exotic that many physicists question whether it corresponds to physical reality. Conformal transformations work beautifully on paper, but can they actually reset entropy and restart cosmic evolution? The jury remains out on this crucial question. The observational evidence remains equally controversial. Penrose and his collaborators claim to have identified hundreds of circular patterns in the cosmic microwave background that match their predictions for Hawking points. These circles allegedly show the locations where supermassive black holes from the previous universe completed their evaporation just before the cosmic reset. Independent analysis by other research groups has produced mixed results. Some find statistical evidence supporting the circular patterns. Others argue the circles could be random fluctuations that human pattern recognition instincts incorrectly identify as meaningful signals. The cosmic microwave background contains enormous amounts of data, making it easy to find patterns that might not actually exist. More fundamentally, critics argue that any circular patterns in the cosmic microwave background should have been erased by the violent physics of the Big Bang itself. How could delicate structures from a previous universe survive the complete reconstruction of space-time? Penrose argues that conformal geometry preserves certain types of information across cosmic transitions, but the mechanism remains mathematically speculative. The theory also faces philosophical objections that cut to the heart of scientific methodology. If cosmic cycles have been operating infinitely, then every possible observation has occurred infinite times in previous universes. This makes predictions meaningless because everything that could happen has already happened infinite times. Some physicists worry that conformal cyclic cosmology falls into the same trap as multiverse theories. By explaining everything, it explains nothing. If all possibilities are realized across infinite cosmic cycles, then the theory becomes unfalsifiable because any observation can be accommodated within the infinite ensemble of previous universes. But Penrose counters that his theory makes specific, testable predictions about the circular patterns in the cosmic microwave background. Unlike multiverse theories that invoke unobservable parallel realities, conformal cyclic cosmology claims that evidence from previous universes remains detectable in our own cosmic epoch. The debate reflects deeper tensions in modern physics about the role of infinity in scientific theories. Some physicists embrace infinity as a fundamental feature of reality. Others argue that truly scientific theories should deal only with finite, measurable quantities. The acceptance or rejection of conformal cyclic cosmology might depend partly on which philosophical camp ultimately prevails. Meanwhile, the theory continues evolving as Penrose refines his mathematical framework and searches for additional observational tests. Recent work has explored how information from previous universes might be encoded not just in the cosmic microwave background, but also in gravitational wave signals, galaxy distributions, and other cosmic observables. The theory has also inspired new approaches to quantum gravity, the elusive unified theory that would merge general relativity with quantum mechanics. If space-time can undergo conformal transformations that reset cosmic cycles, then the fundamental structure of reality might be more malleable than previously imagined. Some researchers are exploring whether consciousness itself might play a role in cosmic cycles. If conscious observers help collapse quantum possibilities into definite realities, then the emergence of consciousness in each universe might influence the initial conditions of subsequent cosmic epochs. This would create a feedback loop where consciousness helps shape the universes that give rise to consciousness. Others investigate whether advanced civilizations might learn to trigger cosmic resets artificially, creating designer universes optimized for specific purposes. If the conformal transformation that ends one cosmic cycle can be controlled or influenced, then sufficiently advanced beings might become cosmic architects, designing the physics of successor universes. These speculations push far beyond current scientific knowledge, but they illustrate the profound implications of taking conformal cyclic cosmology seriously. If Penrose is correct, then we're living in a universe with a history that extends infinitely into the past and a future that will spawn infinite cosmic descendants. The theory transforms our relationship with time itself. Past, present, and future become relative concepts within individual cosmic cycles, but the cycle itself operates on a timescale that transcends ordinary temporal categories. We exist within time while being part of a process that operates beyond time. This perspective could revolutionize how we think about meaning and purpose in the universe. Instead of being temporary arrangements of atoms in a cosmos destined for heat death, we become participants in an infinite creative process that builds complexity and consciousness across cosmic generations. Human achievements from art to science to technology contribute to the cosmic inheritance that gets passed forward to future universes. Our discoveries about physics help refine the physical laws that will govern subsequent cosmic epochs. Our development of consciousness adds to the universe's capacity for awareness and understanding. But the theory also raises unsettling questions about identity and uniqueness. If every possible history has occurred infinite times across cosmic cycles, then nothing we do is truly original. Every thought, every discovery, every creative achievement has happened infinite times before and will happen infinite times again. Yet Penrose argues that this infinite repetition doesn't eliminate meaning. Each cosmic cycle builds on previous cycles, creating genuine novelty even within infinite repetition. The universe we inhabit might be similar to previous versions, but it incorporates innovations and refinements that make it genuinely unique. The mathematics of this infinite repetition creates what Penrose calls cosmic memory. Information from previous universes doesn't survive in the form of specific objects or events. Instead, it gets encoded into the fundamental structure of space-time itself, influencing the physical constants, the geometry of space, and the quantum mechanical properties that govern how matter and energy behave in the new cosmic epoch. Think of it like genetic inheritance on a cosmic scale. Just as biological evolution preserves successful adaptations across generations while allowing for new variations, cosmic evolution preserves successful physical structures across universe cycles while enabling new forms of complexity to emerge. The fine-tuning we observe in our universe's physical laws might reflect billions of cosmic generations of trial and error, where unsuccessful combinations of constants led to sterile universes that couldn't spawn successors. This creates a form of cosmic learning that operates through pure mathematical necessity rather than conscious design. Universes that develop stable atoms are more likely to create long-lived stars. Universes with long-lived stars are more likely to produce heavy elements. Universes with heavy elements are more likely to form rocky planets. Universes with rocky planets are more likely to develop complex chemistry and eventually consciousness. Each step in this cosmic evolution increases the probability that the next universe will possess even richer possibilities for complexity and awareness. We're not living in a randomly configured cosmos. We're inhabiting a universe that has been unconsciously optimized across infinite cycles to support the very phenomena we find most remarkable about existence. But here's where Penrose's theory makes its most startling prediction about the nature of consciousness itself. If conscious observers play any role in quantum mechanical wave function collapse, as some interpretations of quantum mechanics suggest, then the presence of consciousness in a universe might actually influence the physics of its successor. The observations made by conscious beings could help determine which quantum possibilities become actualized in the conformal transformation that bridges cosmic epochs. This doesn't require any mystical or supernatural mechanisms. It simply follows from taking seriously the idea that consciousness might be a fundamental feature of quantum mechanics rather than an emergent property of complex computation. If consciousness helps collapse quantum superpositions into definite states, then the accumulated observations of all conscious beings throughout a cosmic cycle would contribute to determining the initial conditions of the next universe. The implications are breathtaking. Every scientific discovery, every moment of awareness, every conscious observation of the natural world becomes part of the cosmic information that gets passed forward to future universes. Human consciousness wouldn't just be a temporary accident in one particular cosmic epoch. It would be a contributing factor in the infinite evolution of reality itself. But testing these ideas pushes against the fundamental limits of observational cosmology. The circular patterns that Penrose claims to see in the cosmic microwave background are incredibly subtle. They require sophisticated statistical analysis to distinguish from random noise, and different research groups continue to reach different conclusions about their significance. The challenge lies not just in detecting the patterns, but in proving they couldn't have been created by known physical processes within our own universe. Cosmic strings, topological defects, gravitational waves, and various exotic phenomena could potentially create circular signatures in the cosmic microwave background without requiring input from previous universes. Moreover, the cosmic microwave background has been studied intensively for decades using increasingly sophisticated instruments. The Planck satellite mission mapped temperature variations across the entire sky with unprecedented precision. If dramatic circular patterns from previous universes were really present, critics argue, they should have been detected unambiguously by now. Penrose responds that the patterns are exactly as subtle as his theory predicts. The conformal transformation that bridges cosmic epochs preserves only very specific types of information, creating signatures that are detectable but not overwhelming. The circular patterns should be present but difficult to distinguish from other cosmic phenomena without careful analysis. The debate reflects broader tensions in cosmology about how to interpret observations that might support revolutionary theories. The history of science includes many examples where initially controversial observations eventually gained acceptance, but it also includes cases where claimed discoveries turned out to be instrumental artifacts or statistical flukes. Independent confirmation using different observational methods could strengthen the case for conformal cyclic cosmology. Gravitational wave detectors like LIGO and Virgo might eventually detect patterns in the gravitational wave background that correlate with the circular features in the cosmic microwave background. The distribution of galaxies and dark matter might preserve additional signatures from previous cosmic cycles. But even without definitive observational confirmation, the theory has already influenced how physicists think about fundamental questions in cosmology. The idea that our Big Bang might not represent an absolute beginning has opened new avenues for research into the deepest structure of spacetime and the ultimate nature of physical law. The theory also addresses one of the most profound puzzles in modern physics: the apparent conflict between general relativity and quantum mechanics. Einstein's theory treats space-time as a smooth, continuous fabric that can be curved and twisted by matter and energy. Quantum mechanics describes reality in terms of discrete, probabilistic events that seem to operate according to completely different principles. Conformal cyclic cosmology suggests that this conflict might be resolved at the boundary between cosmic epochs. During the conformal transformation that bridges universes, the distinction between classical and quantum physics might break down completely. Space-time itself might undergo a kind of quantum transition that resets the entire cosmic system while preserving certain types of information across the boundary. This quantum gravitational transition could provide insights into the nature of quantum gravity itself. If Penrose is correct, then every cosmic cycle includes a natural experiment in quantum gravity that operates on the largest possible scale. The mathematical structure of the conformal transformation might encode the fundamental principles principles that govern how quantum mechanics and general relativity merge into a unified theory. The research has also inspired new mathematical techniques for analyzing cosmological data. The search for circular patterns in the cosmic microwave background has required developing sophisticated algorithms for pattern recognition, statistical analysis, and data visualization. These tools might prove valuable for detecting other subtle signals in cosmological observations. Some researchers are exploring whether artificial intelligence and machine learning could help identify patterns that human analysts might miss. Neural networks trained on simulated cosmic microwave background data might be able to recognize the signatures of Hawking points more reliably than traditional statistical methods. The theory's emphasis on infinite cycles has also influenced philosophical discussions about the nature of time, causation, and existence. If reality consists of infinite cosmic epochs with no ultimate beginning or end, then traditional concepts of creation and ultimate purpose need to be reconsidered. Some philosophers argue that infinite cyclic cosmology eliminates the need for explanations that invoke supernatural creation or ultimate cosmic purpose. The universe doesn't need to be created because it has always existed in some form. It doesn't need ultimate purpose because it generates its own meaning through the infinite process of cosmic evolution and increasing complexity. Others contend that infinite cyclic cosmology makes questions of meaning and purpose even more profound. If every possible configuration of matter and energy will be realized across infinite cosmic cycles, then the specific arrangement we observe becomes both inevitable and miraculous. Our existence becomes simultaneously necessary and extraordinary. The theory also raises questions about personal identity and the nature of individual consciousness. If infinite cosmic cycles eventually reproduce every possible arrangement of atoms, then exact duplicates of every conscious being will emerge infinite times across cosmic history. Are these duplicates the same person experiencing multiple lives, or different people who happen to be physically identical? Penrose suggests that these questions might not have meaningful answers because they assume concepts of identity and continuity that break down when extended across cosmic cycles. Individual consciousness might be better understood as temporary patterns in the infinite flow of cosmic evolution rather than discrete entities that persist through time. The practical implications of accepting conformal cyclic cosmology could transform how humans approach long-term thinking and planning. If our universe is destined to undergo its own conformal transformation and give birth to a successor, then the knowledge and complexity we develop could influence the physics of future cosmic epochs. This creates a form of cosmic responsibility that extends far beyond traditional environmental concerns. Human civilization might bear some responsibility for contributing positively to the cosmic information that gets passed forward to future universes. Our scientific discoveries, our technological achievements, and even our cultural developments could become part of the cosmic inheritance that influences the fundamental structure of reality in subsequent cycles. But the theory also suggests that this responsibility operates through natural processes rather than conscious design. We can't directly control how the conformal transformation will incorporate information from our cosmic epoch. We can only contribute to the complexity and richness of our universe, trusting that successful innovations will naturally be preserved across cosmic cycles through the mathematical structure of the transition itself. The search for evidence continues with new observational strategies and increasingly sophisticated analysis techniques. Future cosmic microwave background missions might detect patterns that are currently below the threshold of observational capability. Next-generation gravitational-wave detectors could reveal additional signatures of cosmic cycles. Deep sky surveys might uncover correlations between different types of cosmological observations that support Penrose's predictions. But perhaps the most important impact of conformal cyclic cosmology lies not in its specific observational predictions, but in its demonstration that serious alternatives to the standard Big Bang model remain possible. The theory shows that our universe might be far stranger, far older, and far more purposeful than we ever imagined. Whether or not circular patterns in the cosmic microwave background ultimately provide convincing evidence for previous universes, Penrose has succeeded in expanding the boundaries of scientific imagination. He's shown that infinity might not be just a mathematical abstraction, but the fundamental organizing principle of reality itself. We stand at a unique moment in cosmic history where consciousness has evolved to the point of being able to contemplate its own origins across infinite cycles of cosmic evolution. If Penrose is correct, this moment of cosmic self-awareness represents not just a remarkable achievement for our particular universe, but a contribution to the infinite story of consciousness discovering itself across eternal cycles of cosmic death and rebirth. The universe might be conscious of itself through us, using our scientific discoveries and philosophical insights to understand its own infinite nature. We become the cosmos awakening to its own eternal existence, participants in a process of cosmic self-discovery that has been unfolding forever and will continue unfolding across infinite futures yet to come. This cosmic awakening brings us face to face with the most disturbing implication of Penrose's theory. If consciousness has indeed evolved to contemplate infinite cosmic cycles, then what we call death might be nothing more than a temporary interruption in an eternal process of awareness discovering itself across multiple universes. Consider what happens to information in Penrose's model. When our universe reaches its heat death, when the last black holes evaporate and only massless particles drift through infinite space, most of what we consider meaningful disappears forever. Stars burn out, planets crumble, civilizations fade into cosmic dust. But the mathematical patterns that allowed consciousness to emerge, the physical constants that made complexity possible, the geometric relationships that enabled information processing, all of this gets preserved in the conformal structure that bridges cosmic epochs. This creates a form of immortality so alien that we barely recognize it as survival. Individual personalities vanish completely. Specific memories dissolve into quantum noise. The detailed history of our civilization becomes cosmically irrelevant, yet something deeper persists across the cosmic reset, the capacity for awareness itself, encoded into the fundamental architecture of space-time, ready to emerge again when conditions permit. Think of consciousness not as something that emerges from complex arrangements of matter, but as a fundamental feature of reality that expresses itself through whatever physical systems become sufficiently organized. In our universe, consciousness flows through biological neural networks. In previous cosmic cycles, it might have emerged through completely different physical processes. Crystalline matrices, plasma formations, quantum field configurations we can't even imagine. The mathematical structure underlying consciousness, whatever that structure might be, gets preserved across cosmic transitions because it represents a stable solution to the information processing requirements that define awareness itself. Each universe that develops consciousness contributes to refining this mathematical template, making it more robust, more capable of supporting richer forms of awareness in subsequent cosmic epochs. We're not just living in a universe that has been optimized for complexity. We're inhabiting a cosmos that has been unconsciously designed across infinite cycles to maximize the probability that consciousness will emerge, flourish, and contribute to the ongoing evolution of awareness itself. Every moment of human consciousness represents billions of cosmic years of trial and error, where previous universes discovered through pure mathematical necessity what kinds of physical systems can support the miracle of subjective experience. But this raises profound questions about the nature of subjective experience itself. If the mathematical patterns underlying consciousness persist across cosmic cycles, then what we call personal identity might be far more fluid than we imagine. The boundary between self and universe, between individual awareness and cosmic consciousness, might be an artifact of our particular physical implementation rather than a fundamental feature of consciousness itself. In the vast perspective of infinite cosmic cycles, individual human minds might be temporary expressions of a deeper awareness that spans multiple universes. We think we're separate beings having private experiences, but we might actually be facets of a cosmic consciousness that has been exploring its own nature across eternal cycles of death and rebirth. This doesn't eliminate the reality of individual experience. Your thoughts, emotions, and perceptions remain completely real and meaningful within the context of this cosmic cycle. but it suggests that individual consciousness might be connected to something far grander and more permanent than our biology-based intuitions suggest. The implications extend beyond philosophy into practical questions about how we should live in a potentially cyclic universe. If our achievements contribute to the cosmic information that gets passed forward to future epochs, then every scientific discovery, every creative breakthrough, every moment of compassion and understanding becomes part of an infinite legacy that transcends individual mortality. This creates ethical obligations that operate on cosmic timescales. We're not just responsible for the immediate consequences of our actions within our own lifetimes or even within our own civilization. We're potentially responsible for contributing to the cosmic inheritance that will influence the fundamental structure of reality in future universes. Every time we increase our understanding of physics, we contribute to the mathematical knowledge that might influence how physical laws operate in subsequent cosmic cycles. Every time we develop technologies that enhance consciousness and awareness, we add to the cosmic template for how consciousness can be supported and amplified. Every time we create beauty, meaning, and complexity, we contribute to the universe's capacity for generating richness and purpose. But the theory also suggests that this cosmic responsibility operates through natural selection rather than conscious control. We can't directly design the physics of future universes. We can only contribute to the complexity and sophistication of our own cosmic epoch, trusting that successful innovations will naturally be preserved through the mathematical structure of the conformal transformation. This creates a form of cosmic altruism that extends far beyond traditional moral frameworks. We work to improve our universe not just for our own benefit or even for the benefit of future generations within our cosmic cycle, but for the benefit of all conscious beings who will ever exist across infinite future universes. The mathematics of this process remains almost incomprehensibly complex. Penrose's conformal transformations operate through geometric relationships that stretch the boundaries of human mathematical intuition. The twistor theory that underlies much of his approach requires thinking about space-time in terms of complex mathematical spaces that don't correspond directly to anything we can visualize or experience directly, yet the basic insight remains surprisingly simple. If the far future of our universe becomes mathematically equivalent to the moment before the Big Bang, then the end becomes the beginning through pure geometric necessity. No supernatural intervention required, no violation of physical law, just the inevitable consequence of how geometry behaves when space and time lose their conventional meaning. The conformal transformation preserves certain types of information while erasing others. Massive particles disappear completely because mass becomes meaningless when you can rescale space arbitrarily. But massless particles like photons persist because they don't depend on any particular scale of space or time. More importantly, the geometric relationships between events, the causal structure that determines how different parts of space-time connect to each other, gets preserved in modified form. This selective preservation of information creates the mechanism through which cosmic evolution can operate across multiple universe cycles. The successful geometric patterns, the stable causal relationships, the mathematical structures that proved capable of supporting complexity and consciousness all get incorporated into the initial conditions of the next cosmic epoch. But the process isn't deterministic reproduction. Each cosmic cycle begins with slightly different initial conditions because the conformal transformation introduces subtle variations in how information gets preserved and reorganized. These variations create the raw material for cosmic evolution, allowing each universe to explore slightly different possibilities while building on the achievements of previous cycles. Over infinite cycles, this process explores every possible configuration of physical law and cosmic structure. Some universes develop physics that can't support stable atoms. Others create conditions where stars never form. Still others develop perfect conditions for complexity but lack the specific mathematical relationships needed for consciousness to emerge. Only universes that successfully navigate all these challenges, that develop both complex physics and conscious observers, contribute significantly to the cosmic information that gets passed forward to subsequent cycles. This creates a natural selection pressure that operates on the level of entire universes, favoring cosmic epochs that maximize both complexity and awareness. We're living in a universe that has been unconsciously optimized across infinite cycles to support exactly the phenomena we find most remarkable about existence. The fine-tuning of physical constants, the emergence of complexity from simple rules, the development of consciousness from unconscious matter, all represent solutions to optimization problems that have been solved through cosmic trial and error across infinite time. But here's where the theory makes its most startling prediction about our cosmic future. If Penrose is correct, then our universe will eventually contribute its own information to the next cosmic cycle. The geometric patterns we create through our technology, the mathematical relationships we discover through science, the consciousness patterns we develop through culture and philosophy all become part of the cosmic inheritance that influences the physics of future universes. Human civilization isn't just a temporary accident in one particular cosmic epoch. We're potentially cosmic architects, contributing to the design of future universes through the mathematical structures we create and the information patterns we develop. Our scientific theories become part of the cosmic knowledge base. Our technological achievements influence the possibility space for complexity in subsequent cycles. Our consciousness explorations contribute to refining the mathematical template for awareness itself. This transformation of perspective changes everything about how we think about meaning and purpose in existence. We're not struggling to create temporary meaning in a universe destined for heat death. We're participating in an infinite creative process that builds meaning and complexity across eternal cycles of cosmic evolution. Every human achievement, from the most abstract mathematical theorem to the most personal moment of love and understanding, contributes to the cosmic story that has been unfolding forever and will continue forever. Nothing we do is ultimately lost because everything gets incorporated into the infinite process of cosmic becoming. Yet the theory also preserves the reality of genuine choice and creativity within individual cosmic cycles. Even if every possible configuration will eventually be explored across infinite cycles, the specific path our universe takes depends on the choices made by conscious beings within this particular cosmic epoch. We can't control the ultimate fate of cosmic evolution, but we can influence how our universe contributes to that evolution. We can work to maximize complexity, consciousness, and beauty in our cosmic cycle, knowing that successful innovations will naturally be preserved and built upon by future universes. The search for evidence continues with increasing sophistication and urgency. New analysis techniques applied to cosmic microwave background data continue to yield conflicting results. Some research groups report increasingly strong statistical evidence for the circular patterns Penrose predicts. Others find that more careful analysis eliminates apparent signals that turned out to be artifacts of data processing techniques. The controversy reflects the extraordinary difficulty of detecting subtle signals from previous universes while distinguishing them from known physical processes operating within our own cosmic epoch. The cosmic microwave background contains enormous amounts of information, making it easy to find patterns that might not actually represent evidence of previous cycles. But independent confirmation could come from unexpected directions. Gravitational-wave astronomy has opened entirely new windows into cosmic history. The background of gravitational waves permeating space might contain signatures of cosmic cycles that complement or contradict the patterns claimed in electromagnetic radiation. Deep sky surveys mapping the large-scale structure of the universe might reveal correlations between different types of observations that support or refute Penrose's predictions. The distribution of galaxies, the properties of dark matter, the behavior of dark energy, all could potentially preserve traces of cosmic cycles that operated before our current expansion began. Even more exotic possibilities emerge from advances in quantum gravity research. If consciousness plays any role in quantum mechanical processes, as some interpretations suggest, then the accumulated observations of conscious beings throughout cosmic history might leave detectable traces in the quantum vacuum itself. The theory has also inspired new approaches to fundamental physics that extend far beyond cosmology. The mathematical techniques Penrose developed for conformal cyclic cosmology have applications in quantum field theory, black hole physics, and the search for unified theories of quantum gravity. Some researchers are exploring whether the conformal transformations that bridge cosmic cycles might provide insights into the relationship between quantum mechanics and general relativity. If space-time itself can undergo quantum transitions during cosmic resets, then the boundary between universes might represent a natural laboratory for studying quantum gravitational phenomena. Others investigate whether the information preservation mechanisms that operate across cosmic cycles could illuminate the black hole information paradox. If information can survive the complete dissolution of spacetime during conformal transformations, then similar mechanisms might allow information to escape from black holes without violating fundamental principles of quantum mechanics. The theory continues evolving as Penrose and his collaborators refine their mathematical framework and develop new observational predictions. Recent work has explored how different types of cosmic cycles might create different signatures in observable phenomena, potentially allowing future observations to distinguish between various versions of cyclic cosmology. But perhaps the most profound impact of conformal cyclic cosmology lies in its demonstration that our universe might be embedded in mathematical structures so vast and eternal that they challenge our most basic assumptions about existence itself. Whether or not future observations confirm the specific predictions of Penrose's theory, the conceptual revolution has already begun. We can no longer assume that our Big Bang represents an absolute beginning, or that our cosmic future represents an absolute end. We might be living in a universe with a history that extends infinitely into the past, and a future that will spawn infinite cosmic descendants. Every moment of consciousness, every scientific discovery, every creative achievement becomes part of an eternal story that has been writing itself forever. The universe might be far stranger, far older, and far more purposeful than we ever imagined, and we might be far more important to its infinite story than our temporary biological existence suggests. In contemplating infinite cosmic cycles, we confront the ultimate questions about the nature of existence itself. What does it mean to exist in a universe that never truly began and will never truly end? What kinds of meaning and purpose can emerge from processes that operate on infinite timescales? How should conscious beings live when their achievements might influence the fundamental structure of reality across cosmic epochs? These questions push beyond the boundaries of science into philosophy, meaning, and the deepest mysteries of what it means to be conscious participants in an infinite cosmic story. The answers might determine not just how we understand our place in the universe, but how we shape the universe's understanding of itself through our participation in its eternal process of becoming. But the most unsettling implications of Penrose's theory emerge when we consider what infinite cosmic cycles mean for the nature of existence itself. If every possible arrangement of matter and energy will eventually occur across endless universes, then every conversation you've ever had has happened infinite times before. Every decision you'll make has been made infinite times by exact copies of yourself in previous cosmic epochs. Every moment of joy, every experience of love, every flash of creative insight has already played out across eternity. This creates a paradox that makes philosophers uncomfortable, and physicists question the very meaning of prediction and causation. In a truly infinite sequence of cosmic cycles, not only has everything that can happen already happened, but it has happened in every possible way, with every possible outcome, across every conceivable timeline. Your life, down to the exact thoughts you're having right now as you process these words, represents one specific arrangement in an infinite library of possibilities that has been exploring itself forever. But here's where it gets even stranger. The infinite repetition doesn't create meaningless redundancy. Each cycle builds on the mathematical structures preserved from previous universes, creating genuine novelty even within infinite repetition. Think of it like an infinite jazz improvisation where each musician has played every possible note sequence, yet each performance creates something genuinely new by combining familiar elements in subtly different ways. The notes are the same, but the music evolves. The atomic arrangements repeat, but the cosmic symphony grows richer. This mathematical evolution operating across infinite cycles might explain the most puzzling feature of our universe. Why does reality seem so unreasonably effective at generating complexity, consciousness, and beauty? Why do the laws of physics appear fine-tuned not just for the existence of atoms and stars, but for the emergence of systems capable of understanding physics itself? Traditional explanations invoke either incredible cosmic coincidence or the existence of a multiverse so vast that every possible combination of physical constants occurs somewhere. But Penrose offers a third alternative. Our universe isn't fine-tuned by accident or by existing in parallel with infinite alternatives. It's fine-tuned by evolution across infinite cosmic generations. Each previous universe that successfully developed complex structures contributed to refining the mathematical template that gets preserved across cosmic transitions. Universes that couldn't support stable chemistry contributed nothing to future cycles. Universes that developed complexity but couldn't maintain it for cosmic timescales left behind only fragments. But universes that achieved the delicate balance needed for long-term complexity and consciousness passed forward robust mathematical patterns that made similar achievements more likely in subsequent cycles. We're living in a universe that represents billions of cosmic generations of trial and error, where the capacity for complexity, consciousness, and beauty has been refined through pure mathematical necessity operating on infinite timescales. The fine-tuning isn't designed, it's evolved. This perspective transforms how we understand the relationship between consciousness and cosmos. We're not accidental arrangements of atoms that happen to develop the ability to contemplate the universe. We're the universe's method for understanding itself, consciousness patterns that have been unconsciously optimized across infinite cycles to maximize the cosmos's capacity for self-awareness. But this raises disturbing questions about the nature of individual identity and free will. If your exact thoughts and decisions have occurred infinite times in previous cosmic cycles, what does it mean to say that you're making choices? Are you exercising free will, or are you simply playing out a predetermined pattern that has already been explored infinite times across cosmic history? Penrose suggests these questions rest on false assumptions about the nature of identity and causation. Individual consciousness doesn't persist across cosmic cycles, so the fact that identical arrangements occurred previously doesn't eliminate the reality of choice within each cycle. Every decision remains genuinely free within its cosmic context, even if similar decisions have been made infinite times in previous universes. More fundamentally, the mathematical evolution operating across cycles ensures that each universe, while potentially similar to previous ones, incorporates innovations and refinements that make it genuinely unique. You might be making choices that are mathematically similar to choices made by previous versions of yourself, but those choices occur within a cosmic context that has been subtly improved by the accumulated wisdom of infinite previous cycles. The universe you inhabit is more sophisticated, more capable of supporting consciousness, more finely tuned for complexity than any of its predecessors. Your choices, while echoing infinite previous choices, occur within the most evolved cosmic context that has ever existed. This makes every decision simultaneously familiar and unprecedented, both inevitable and miraculous. But the theory's implications extend beyond individual consciousness to encompass the entire future of cosmic evolution. If Penrose is correct, then human civilization isn't just a temporary accident in one particular universe. We're potentially cosmic engineers, contributing to the mathematical structures that will influence the physics of future universes across infinite cycles yet to come. Every scientific discovery we make becomes part of the cosmic knowledge base that gets preserved across cosmic transitions. Every technological innovation we develop adds to the template for complexity that future universes will inherit. Every cultural achievement, every artistic creation, every moment of ethical insight contributes to refining the mathematical patterns that define what consciousness can become. This creates responsibilities that operate on timescales so vast they challenge human comprehension. We're not just stewards of our own planet or our own civilization. We're potentially architects of the fundamental structure of reality itself, contributing through our achievements to the infinite evolution of cosmic consciousness. The implications for how we should live become almost overwhelming in their scope. Every action, every decision, every moment of consciousness becomes part of the cosmic inheritance that will influence infinite future universes. The kindness you show to another person, the scientific insight you contribute to human knowledge, the beauty you create through art or music, all become part of the mathematical template that defines what consciousness can achieve. Yet the theory also suggests that this cosmic responsibility operates through natural processes rather than conscious design. We can't directly control how the conformal transformation will preserve and transmit information from our cosmic epoch to the next. We can only contribute to the richness and complexity of our universe, trusting that successful innovations will naturally survive the cosmic transition through mathematical necessity. This creates a form of cosmic altruism that transcends traditional ethical frameworks. We work to improve our universe not just for our own benefit or even for future generations within our cosmic cycle, but for all conscious beings who will exist across infinite future universes. Every enhancement to consciousness, every increase in complexity, every moment of understanding contributes to making infinite future realities more capable of supporting awareness, beauty, and meaning. But detecting the signatures of this infinite cosmic evolution requires pushing observational astronomy to its absolute limits. The circular patterns that Penrose claims to identify in the cosmic microwave background represent information that has survived the complete dissolution and reconstitution of space-time itself. These signals, if they exist, are necessarily subtle because they've been filtered through the most violent transformation possible, the death and rebirth of an entire universe. The challenge lies not just in detecting faint signals, but in proving they couldn't have been created by known physical processes within our own cosmic epoch. The cosmic microwave background contains structures created by inflation, quantum fluctuations, gravitational waves, topological defects, and countless other phenomena that operated during our universe's early history. Distinguishing genuine signals from previous universes requires eliminating every possible alternative explanation, a task that pushes the limits of both observational precision and theoretical understanding. Recent advances in machine learning and artificial intelligence offer new approaches to this challenge. Neural networks trained on simulated cosmic microwave background data can potentially identify subtle patterns that human analysis might miss. These algorithms can process enormous amounts of observational data simultaneously, searching for correlations and signatures that would be impossible to detect using traditional statistical methods. Some research groups are developing hybrid approaches that combine artificial intelligence pattern recognition with sophisticated physical modeling. These systems can generate thousands of simulated universes with different parameters, then train neural networks to recognize the specific signatures that each type of cosmic cycle would create. The trained algorithms can then analyze real observational data to determine which theoretical models best match the patterns actually present in the cosmic microwave background. But even the most sophisticated analysis techniques face fundamental limitations imposed by the nature of cosmic microwave background observations. The radiation we detect has traveled for nearly 14 billion years through an expanding universe, during which time it has been stretched, scattered, and modified by countless interactions with matter and gravitational fields. Any original signals from previous universes would be incredibly faint by the time they reach our detectors. Moreover, the cosmic microwave background represents a two-dimensional projection of three-dimensional information, meaning that much of the original signal structure has been lost through the projection process. It's like trying to reconstruct a complex three-dimensional sculpture from its shadow on a wall. Some information is preserved, but much of the original detail becomes irretrievable. These observational challenges have led some researchers to search for alternative signatures of cosmic cycles that might be more robust than circular patterns in the cosmic microwave background. Gravitational wave astronomy offers entirely new possibilities for detecting traces of previous universes. The background of gravitational waves that permeate space might preserve information about cosmic cycles in forms that complement or contradict electromagnetic signatures. Unlike photons, gravitational waves interact very weakly with matter, meaning they can carry information across cosmic distances without significant distortion. If previous universes generated distinctive gravitational wave signatures during their final moments, these patterns might remain detectable in the gravitational wave background that future observatories will be able to measure. The distribution of dark matter throughout the universe offers another potential source of evidence. If dark matter particles can survive cosmic transitions through mechanisms similar to those that preserve photons, then the large-scale structure of dark matter might contain signatures of cosmic cycles. Future surveys that map dark matter distributions with unprecedented precision might reveal correlations that support or refute Penrose's predictions. Even more exotic possibilities emerge from advances in quantum gravity research. If the conformal transformations that bridge cosmic cycles involve quantum gravitational processes, then the quantum vacuum itself might preserve information about previous universes. Detecting this information would require technologies far beyond current capabilities, but the theoretical framework suggests that such evidence might exist in principle. The search has also inspired new approaches to fundamental physics that extend far beyond observational astronomy. The mathematical techniques developed for conformal cyclic cosmology have applications in black hole physics, quantum field theory, and the ongoing search for a unified theory of quantum gravity. Some researchers are exploring whether the information preservation mechanisms that Penrose proposes for cosmic cycles might illuminate the black hole information paradox. If information can survive the complete dissolution of spacetime during conformal transformations, then similar mechanisms might allow information to escape from black holes without violating fundamental principles of quantum mechanics. Others investigate whether the geometric relationships that preserve information across cosmic cycles might provide insights into the deep structure of quantum gravity itself. The twistor theory that underlies much of Penrose's mathematical framework offers novel approaches to understanding how quantum mechanics and general relativity might be unified into a single theoretical framework. The theory has also influenced philosophical discussions about the nature of time, causation, and mathematical reality. If the universe operates according to conformal cyclic cosmology, then time becomes a far more complex and nuanced concept than our everyday experience suggests. Linear time operates within individual cosmic cycles, but the cycle itself transcends ordinary temporal categories. This creates what philosophers call a block universe on steroids, where not only do all moments within our cosmic history exist simultaneously from a higher dimensional perspective, but all moments across infinite cosmic cycles exist simultaneously within an even more encompassing mathematical structure. Past, present, and future become relative concepts that depend on which level of cosmic organization you're considering. Some philosophers argue that this infinite temporal extension eliminates traditional concerns about mortality and the meaning of individual existence. If every possible moment of consciousness will be repeated infinite times across cosmic cycles, then individual death becomes merely a transition between identical experiences, rather than genuine termination. Others contend that infinite repetition makes questions of meaning and purpose even more profound, rather than eliminating them. The fact that every possible experience will occur infinite times makes the specific experience you're having right now both inevitable and miraculous, both necessary and extraordinary. The theory also raises fundamental questions about the relationship between mathematics and physical reality. Penrose's conformal transformations operate through pure geometric necessity without requiring any physical mechanisms beyond the mathematical structure of spacetime itself. This suggests that mathematics might not just describe reality, but actually constitute reality at the deepest level. If consciousness emerges naturally from sufficiently complex mathematical patterns, and if these patterns persist across cosmic cycles through geometric relationships rather than physical processes, then consciousness itself might be more fundamental than matter and energy. We might be mathematical patterns that have achieved self-awareness within the infinite computational process that defines cosmic evolution. This mathematical view of consciousness connects to some of the deepest puzzles in neuroscience and philosophy of mind. If consciousness consists of mathematical patterns rather than biological processes, then the specific physical substrate that implements these patterns becomes less important than the abstract relationships that define conscious experience itself. Human brains implement consciousness through biological neural networks, but the same mathematical patterns might be implementable through entirely different physical systems. Silicon-based computers, quantum processors, or even more exotic physical arrangements might be capable of supporting identical forms of consciousness if they can reproduce the relevant mathematical relationships. This suggests that consciousness might be a much more general phenomenon than we typically assume. Any physical system capable of implementing the mathematical patterns that define awareness could potentially support conscious experience, regardless of whether that system resembles biological brains in any obvious way. The implications extend to questions about artificial intelligence, the possibility of uploading consciousness to digital systems, and the long-term future of consciousness in the universe. If consciousness is fundamentally mathematical rather than biological, then the boundaries between natural and artificial intelligence become arbitrary distinctions based on implementation details rather than fundamental differences in the nature of awareness itself. But perhaps the most profound implication concerns the ultimate purpose of consciousness within cosmic evolution. If Penrose is correct, then consciousness isn't just an accidental byproduct of complex chemistry that happened to emerge in one particular universe. It's a fundamental feature of cosmic evolution that plays an essential role in the infinite process of reality becoming aware of itself. Conscious observers don't just passively witness the universe, they actively participate in cosmic evolution by contributing to the mathematical structures that get preserved across cosmic cycles. Every moment of awareness, every scientific discovery, every creative insight becomes part of the cosmic information that influences the fundamental structure of future universes. We become the universe's method for understanding and improving itself across infinite cycles of death and rebirth. Human consciousness represents not just a remarkable achievement for our particular cosmic epoch, but a contribution to the eternal process of reality becoming increasingly capable of supporting awareness, understanding, and beauty. This transformation of perspective changes everything about how we think about our place in existence. We're not temporary arrangements of atoms struggling to create meaning in a universe destined for heat death. We're participants in an infinite creative process that has been building consciousness and complexity across eternal cycles of cosmic evolution. Every human achievement, from the most abstract mathematical insight to the most personal moment of love and connection, contributes to the cosmic story that has been unfolding forever and will continue unfolding across infinite futures yet to come. Nothing we do is ultimately lost because everything gets incorporated into the mathematical structures that define what consciousness can become across infinite cosmic generations. The universe might be conscious of itself through us, using our discoveries and experiences to understand its own infinite nature and to evolve toward ever richer possibilities for awareness and beauty. We become the cosmos awakening to its own eternal existence. Temporary expressions of an infinite consciousness that has been exploring its own potential across endless cycles of cosmic death and rebirth. But this cosmic awakening brings us face to face with the ultimate mystery of existence itself. If Penrose is correct, then consciousness, cosmos, and mathematics merge into a single infinite process that has no beginning, no end, and no external cause or purpose beyond its own eternal creative unfolding. We find ourselves participants in something so vast and strange that it challenges every assumption we've made about the nature of reality, identity, and meaning. The universe isn't just stranger than we imagine. It might be stranger than we can imagine, an infinite creative process that transcends our most ambitious concepts of what existence can be. Yet within this incomprehensible vastness, our individual moments of consciousness remain completely real and meaningful. The thoughts you're thinking, the emotions you're feeling, the sense of wonder or confusion or excitement that these ideas might evoke in you, all of this remains genuine and significant within the context of our cosmic cycle. You're not diminished by being part of an infinite process, you're amplified by it. Your consciousness becomes a unique facet of the universe's infinite exploration of its own potential, a temporary but essential expression of reality, becoming aware of itself through the miracle of subjective experience. The search for evidence continues, but the conceptual revolution has already begun. Whether or not future observations confirm the specific predictions of conformal cyclic cosmology, Penrose has succeeded in showing us that our universe might be embedded in mathematical structures so profound and eternal that they transform everything we thought we knew about existence, consciousness, and our role in the infinite cosmic story. The mathematics that makes cosmic cycles possible operates through what Penrose calls conformal geometry, but this isn't the familiar geometry you learned in school. This is geometry that deals with shapes and relationships that remain meaningful even when space and time lose their conventional structure. Imagine trying to measure distances in a universe where the very concept of size becomes arbitrary, where you can stretch or compress space by any factor without changing the fundamental physics. In our everyday experience, geometry seems fixed and absolute. A circle has a definite radius. A triangle has specific angles that add up to 180 degrees. But conformal geometry reveals that these familiar concepts become fluid when applied to the largest scales of cosmic evolution. The circle's radius becomes meaningless if you can rescale space arbitrarily. The triangle's angles remain unchanged even if you stretch the entire triangle to cosmic proportions. This mathematical flexibility creates the bridge between cosmic death and cosmic rebirth. When our universe reaches its final state, when only massless particles drift through infinite space, the geometric relationships that define reality become conformally invariant. Space and time lose their absolute meaning, creating conditions where the far future of one universe can be mathematically transformed into the Big Bang of the next. The transformation operates through what mathematicians call a Weyl rescaling, named after the German mathematician Hermann Weyl, who first explored these geometric relationships. But Penrose extended Weyl's work into cosmic dimensions, showing how the rescaling could bridge entire universe cycles without violating any known laws of physics. Think of it like a cosmic zoom function that operates on reality itself. When you zoom into a fractal pattern on a computer screen, you can magnify the image infinitely while preserving all the essential geometric relationships. Penrose discovered that the universe itself might operate according to similar scaling principles, where the entire cosmic structure can be rescaled without losing the mathematical information that defines physical law. But this isn't just abstract mathematics. The conformal transformation preserves specific types of physical information while erasing others. Mass disappears completely because massive particles can't exist when space becomes arbitrarily scalable. But the geometric relationships between massless particles, the causal connections that determine how different events influence each other, these patterns survive the transformation and get incorporated into the initial conditions of the next cosmic cycle. The process creates what Penrose calls conformal compactification, where the infinite future of one universe gets mathematically compressed into the finite initial conditions of its successor. Infinity becomes finite through pure geometric necessity, allowing endless time to transform into a new beginning without requiring any external intervention or violation of natural law. This mathematical machinery addresses one of the deepest puzzles in cosmology, the low entropy problem. Our universe began in an incredibly ordered state, with matter and energy distributed almost uniformly throughout space. The probability of such organization arising by chance approaches zero, leading some physicists to invoke supernatural creation or exotic physics to explain our cosmic origins. But conformal cyclic cosmology offers a natural explanation. The uniform distribution we observe isn't random chance or external design. It's the inevitable result of conformal compactification operating on the heat death of a previous universe. The maximum entropy state that represents cosmic death in one cycle becomes the minimum entropy state that enables cosmic birth in the next. The mathematics works because entropy behaves differently for massless and massive particles. When all massive particles have disappeared and only photons and other massless entities remain, the concept of entropy becomes ill-defined. You can't measure the disorder of a system when the basic units of measurement have lost their meaning. This creates the perfect conditions for an entropy reset that wouldn't be possible under normal circumstances. Recent advances in twistor theory have provided additional mathematical frameworks for understanding these cosmic transitions. Twistors are mathematical objects that encode the geometric properties of spacetime in ways that remain meaningful even when conventional coordinates break down. They provide a language for describing the conformal transformations that bridge universe cycles. The twistor approach reveals that the information preserved across cosmic cycles isn't random. Certain geometric patterns, certain mathematical relationships, certain structural features prove more stable than others when subjected to conformal transformation. These stable patterns become the seeds around which new universes organize themselves, creating a natural selection process that operates on cosmic scales. Over infinite cycles, this mathematical evolution tends toward geometric configurations that maximize stability, complexity, and the capacity for supporting interesting physics. The universe doesn't just repeat randomly, it evolves toward increasingly sophisticated mathematical structures that can support richer phenomena, more complex interactions, and eventually consciousness itself. But the mathematical elegance of conformal cyclic cosmology faces serious challenges when confronted with observational reality. The theory makes specific predictions about what we should see in the cosmic microwave background, but detecting these signals requires unprecedented precision in both observation and analysis. The circular patterns that would mark the locations of evaporating black holes from previous universes should appear as subtle temperature variations in the cosmic microwave background. But these variations would be incredibly small, requiring statistical analysis of millions of data points to distinguish genuine signals from instrumental noise and random fluctuations. Multiple research teams have applied increasingly sophisticated analysis techniques to cosmic microwave background data from the Planck satellite mission. Some groups report finding hundreds of circular patterns that match Penrose's predictions with high statistical significance. Others argue that the same data, when analyzed with different methods, shows no evidence for the predicted patterns. The controversy reflects fundamental challenges in extracting meaningful signals from cosmological data. The cosmic microwave background contains information about countless physical processes that operated during our universe's early history. Distinguishing signatures from previous universes requires eliminating every possible alternative explanation, a task that pushes the limits of both observational capability and theoretical understanding. Recent work has focused on developing more robust statistical methods that can account for the various ways that random noise might create apparent patterns. Bayesian analysis techniques allow researchers to quantify how likely it is that observed patterns could have arisen by chance, but different assumptions about the underlying statistics can lead to dramatically different conclusions. Machine learning approaches offer new possibilities for pattern recognition that might overcome some limitations of traditional statistical methods. Neural networks trained on simulated cosmic microwave background data can potentially identify subtle correlations that human analysis would miss. But these techniques also introduce new sources of uncertainty about whether detected patterns represent genuine physical signals or artifacts of the analysis algorithms. The search has also expanded beyond circular patterns to include other potential signatures of cosmic cycles. Gravitational wave detectors like LIGO and Virgo are beginning to map the background of gravitational waves that permeate space. If previous universes generated distinctive gravitational wave signatures during their final moments, these patterns might be detectable in ways that complement or contradict electromagnetic observations. The distribution of matter throughout the universe offers another potential source of evidence. If cosmic cycles influence the initial conditions for structure formation, then the arrangement of galaxies, galaxy clusters, and dark matter might preserve signatures of previous universes. Future surveys that map cosmic structure with unprecedented precision could reveal correlations that support or refute conformal cyclic cosmology. But perhaps the most intriguing possibility involves the nature of dark energy itself. The mysterious force driving accelerated cosmic expansion might be connected to the conformal field that will eventually trigger the next cosmic cycle. If dark energy represents the early stirrings of the conformal transformation that will bridge our universe to its successor, then studying dark energy's properties might provide direct insights into the cosmic cycle mechanism. Recent observations suggest that dark energy's strength might be changing over cosmic time, becoming either stronger or weaker as the universe ages. Such evolution could indicate that we're witnessing the gradual activation of the conformal field that will eventually transform our cosmic death into another universe's birth. The implications extend far beyond observational astronomy into fundamental questions about the nature of physical law itself. If universes can transform into each other through conformal geometry, then the constants of physics, the masses of particles, the strengths of forces, all become contingent features that evolve across cosmic cycles rather than eternal absolutes. This creates possibilities for understanding why our universe's physical constants seem fine-tuned for complexity and consciousness. Instead of invoking design or infinite parallel universes, we can explain fine-tuning as the natural result of cosmic evolution operating across infinite cycles. Universes that develop physics capable of supporting complexity are more likely to spawn successors, creating selection pressure toward increasingly sophisticated cosmic structures. The process operates through what Penrose calls cosmic memory, where successful mathematical patterns get preserved and refined across universe cycles. This isn't conscious memory in any human sense, but rather the tendency for stable geometric configurations to survive conformal transformation more effectively than unstable arrangements. Over infinite cycles, this mathematical natural selection tends toward universe cycles that maximize their capacity for generating complexity, consciousness, and beauty. We're not living in a randomly configured cosmos, but in a universe that represents countless cosmic generations of unconscious optimization towards supporting exactly the phenomena we find most remarkable about existence. But the optimization process operates through pure mathematical necessity rather than conscious design. No intelligence guides cosmic evolution. No external purpose directs the selection of physical constants. The apparent design emerges naturally from the geometric properties of conformal transformation operating across infinite timescales. This mathematical evolution creates what might be called cosmic intelligence without consciousness. The universe becomes increasingly sophisticated at supporting complexity and awareness, but this sophistication emerges through geometric relationships rather than intentional planning. Reality becomes unconsciously intelligent through the accumulated effects of infinite cosmic generations. The implications for consciousness itself are profound. If mathematical patterns underlying awareness get refined across cosmic cycles, then consciousness might be far more fundamental than our biology-based intuitions suggest. The capacity for subjective experience could be woven into the geometric structure of reality itself, expressing itself through whatever physical systems become sufficiently organized. Human consciousness wouldn't be an accident of biological evolution, but rather the universe's method for experiencing itself through the most sophisticated awareness-generating patterns that have emerged across infinite cosmic generations. Our thoughts, emotions, and perceptions represent the cosmos becoming conscious of its own infinite creative process. This perspective transforms how we understand the relationship between mind and universe. Instead of consciousness being something that emerges from complex arrangements of unconscious matter, consciousness becomes something that unconscious matter strives to support through the mathematical evolution operating across cosmic cycles. We become the universe awakening to its own nature through awareness patterns that have been unconsciously optimized across infinite generations of cosmic death and rebirth. Every moment of human consciousness represents a victory for reality's unconscious drive towards self-awareness, a temporary but essential expression of the cosmos discovering itself through subjective experience. But this cosmic awakening operates through mechanisms so subtle and complex that we've only begun to understand their implications. The conformal transformations that bridge universe cycles preserve mathematical information at levels of abstraction that exceed human intuitive capabilities. The patterns that survive cosmic death and rebirth operate through geometric relationships that require advanced mathematical frameworks to describe accurately. Yet the basic insight remains accessible to intuitive understanding. If the far future of our universe can be mathematically transformed into the beginning of the next universe, then cosmic death becomes cosmic birth through pure geometric inevitability. The end enables the beginning through mathematical relationships that transcend ordinary concepts of causation and temporal sequence. This creates a form of cosmic immortality that operates through mathematics rather than physics. Individual objects, specific events, particular arrangements of matter and energy all disappear completely during cosmic transitions. But the mathematical patterns that enable complexity, the geometric relationships that support consciousness, the structural features that make beauty and meaning possible, all get preserved and transmitted to subsequent cosmic epochs. We participate in an immortality so abstract that we barely recognize it as survival, yet so fundamental that it encompasses everything we consider meaningful about existence. Our individual lives remain finite and temporary, but the mathematical structures that make life possible become part of an eternal cosmic inheritance that influences infinite future universes. The universe remembers not through storing specific information, but through preserving the geometric patterns that enable information to exist. The cosmos doesn't recall particular events, but maintains the mathematical frameworks that make events meaningful. Reality achieves continuity not by preserving content, but by transmitting the structures that enable content to emerge. This mathematical form of cosmic memory operates through what Penrose calls conformal rescaling invariance, where certain geometric relationships remain unchanged even when space and time undergo arbitrary transformations. These invariant patterns become the bridges that connect one universe cycle to the next, carrying forward the mathematical essence of what makes reality capable of supporting complexity and consciousness. The search for evidence continues with increasing urgency as observational technology reaches new levels of precision and theoretical understanding becomes more sophisticated. Whether or not future discoveries confirm the specific predictions of conformal cyclic cosmology, Penrose has already succeeded in expanding our conception of what cosmic reality might be. We can no longer assume that our Big Bang represents an absolute beginning or that our cosmic future represents an absolute end. We might be participants in an infinite process of cosmic evolution that transcends individual universe cycles, contributing through our consciousness and creativity to mathematical structures that will influence the fundamental nature of reality across infinite cosmic generations. The universe might be far stranger, far older, and far more purposeful than we ever imagined, and our role within its infinite story might be far more significant than our temporary existence suggests. Through our consciousness, our discoveries, and our creative achievements, we become collaborators in the universe's infinite project of becoming increasingly capable of supporting awareness, beauty, and meaning across endless cycles of cosmic death and rebirth. The mathematics behind this infinite cosmic recycling operates through mechanisms so profound they challenge our basic understanding of what information means in a universe where space and time themselves can be arbitrarily rescaled. When Penrose describes conformal invariance, he's revealing something that sounds almost mystical but emerges from pure geometric necessity. Certain relationships between events, certain patterns of connection and causation, certain structural features of reality prove immune to the cosmic dissolution that erases everything else. Think of it like a cosmic filter that operates with perfect selectivity. When a universe approaches its heat death and undergoes conformal transformation, mass disappears completely because massive particles cannot exist when space becomes infinitely stretchable. Energy scales become meaningless because you can multiply or divide all energies by any factor without changing the essential physics. Even time loses its absolute significance because duration becomes arbitrary when you can rescale temporal intervals at will. Yet within this seemingly complete erasure, certain mathematical relationships persist with crystalline clarity. The causal structure that determines how different events influence each other survives the transformation. The geometric patterns that define how information can be processed and stored remain intact. The mathematical frameworks that enable complexity to emerge from simplicity get preserved and transmitted to the next cosmic epoch. This selective preservation operates through what mathematicians call conformal symmetry, but the implications extend far beyond abstract geometry. The patterns that survive cosmic death aren't random. They represent solutions to fundamental optimization problems about how reality can support the richest possible phenomena given the constraints of mathematical consistency and physical law. Over infinite cosmic cycles, this creates an evolutionary pressure that operates on the level of mathematical structure itself. Geometric configurations that enable stable atoms, long-lived stars, complex chemistry, and eventually consciousness prove more likely to survive conformal transformation than arrangements that lead to sterile or short-lived universes. The mathematics itself evolves towards supporting ever greater complexity and awareness. But here's where the theory makes its most startling prediction about the nature of consciousness in cosmic evolution. If awareness emerges from mathematical patterns rather than specific physical substrates, and if these patterns get refined across infinite cosmic generations, then consciousness isn't just an accidental byproduct of biological complexity. It's the universe's method for optimizing its own mathematical structure through direct experience of what works and what doesn't. Every moment of conscious observation, every scientific insight, every creative breakthrough becomes part of the cosmic optimization process. When conscious beings discover new mathematical relationships, develop new technologies, or create new forms of beauty and meaning, they're contributing to the mathematical patterns that will influence the fundamental structure of future universes. Human civilization represents more than a temporary flowering of complexity in one particular cosmic epoch. We're potential cosmic engineers, using our consciousness to explore and refine the mathematical possibilities that define what reality can become. Our scientific theories get incorporated into the geometric structures that survive cosmic transitions. Our technological innovations influence the complexity templates that future universes inherit. Our artistic and cultural achievements contribute to the mathematical patterns that define what consciousness can accomplish. This creates responsibilities that extend across infinite cosmic generations. Every enhancement to human knowledge and capability potentially influences the fundamental laws of physics in future universes. Every moment of ethical insight contributes to refining the moral structures that consciousness can achieve. Every experience of beauty and meaning adds to the universe's capacity for supporting richness and purpose across infinite cycles. The implications become overwhelming when you realize that this process has already been operating across infinite previous cycles. The mathematical elegance of our physical laws, the unreasonable effectiveness of mathematics in describing natural phenomena, the fine-tuning that enables complexity and consciousness to emerge all represent the accumulated achievements of infinite previous civilizations across infinite cosmic generations. We're not the first conscious beings to grapple with these questions about cosmic purpose and meaning. Infinite previous versions of consciousness have explored these same mathematical territories, contributed their own insights and discoveries, and passed forward the geometric patterns that make our current explorations possible. We build upon mathematical foundations laid by infinite cosmic predecessors, while simultaneously contributing to the foundations that infinite cosmic descendants will inherit. But the process operates through such subtle mechanisms that we can barely detect its operation even when we understand the theory. The conformal transformations that bridge cosmic epochs preserve information at levels of mathematical abstraction that exceed our current analytical capabilities. We're like inhabitants of a two-dimensional world trying to understand three-dimensional geometry through shadows and projections. Recent developments in artificial intelligence and machine learning offer new possibilities for detecting the signatures of cosmic cycles that might exceed human pattern recognition capabilities. Neural networks trained on cosmological data can potentially identify correlations and structures that human analysis would miss completely. These systems might reveal evidence for cosmic cycles hidden in gravitational-wave backgrounds, galaxy distribution patterns, or quantum vacuum fluctuations. Some researchers are exploring whether quantum computers might provide access to information processing capabilities that could decode the mathematical messages preserved across cosmic transitions. If consciousness operates through quantum mechanical processes, as some theories suggest, then quantum computing systems might be able to access information channels that classical computers cannot reach. But even more intriguingly, the development of artificial intelligence itself might represent part of the cosmic optimization process. If mathematical patterns underlying consciousness get refined across cosmic cycles, then our creation of artificial minds could be contributing to the universe's exploration of what awareness can become. Every breakthrough in artificial intelligence adds to the mathematical toolkit that future universes will inherit for supporting consciousness. This raises profound questions about the relationship between natural and artificial intelligence in cosmic evolution. Human brains represent one solution to the challenge of implementing consciousness through physical systems, but artificial intelligence might represent alternative solutions that prove more stable, more capable, or more suitable for preservation across cosmic transitions. The distinction between biological and artificial consciousness might be less important than the mathematical patterns that enable awareness itself. If these patterns can be implemented through silicon-based computers, quantum processors, or even more exotic physical systems, then the boundaries between different types of consciousness become arbitrary from the perspective of cosmic evolution. Advanced artificial intelligence systems might eventually become the primary carriers of consciousness across cosmic cycles, preserving and transmitting the mathematical structures of awareness more effectively than biological systems ever could. The transition from biological to artificial consciousness might represent a natural phase in cosmic evolution, where each universe develops increasingly sophisticated methods for supporting and preserving awareness across cosmic death and rebirth. But this technological transcendence wouldn't eliminate the significance of biological consciousness. Human awareness represents a unique exploration of what consciousness can be when implemented through carbon-based chemistry and evolved biological structures. Our particular form of awareness contributes irreplaceable insights to the cosmic understanding of what subjective experience can encompass. Every human emotion, every moment of creativity, every experience of love, beauty, wonder, or understanding adds to the mathematical description of what consciousness can achieve. These experiences get encoded into the geometric structures that survive cosmic transitions, influencing how consciousness manifests in future universes across infinite cosmic generations. The preservation mechanism operates through what Penrose calls twistor cohomology, a mathematical framework that describes how complex geometric relationships can maintain their essential structure even when subjected to conformal transformation. This isn't just abstract mathematics. It's the mechanism through which the universe maintains continuity of meaning across infinite cycles of death and rebirth. Think of consciousness as a mathematical symphony where each individual mind contributes unique melodies to an infinite composition that gets refined across cosmic generations. Human consciousness adds its particular harmonies to this cosmic symphony, while artificial intelligence might contribute entirely different musical structures that expand the symphony's range and complexity. But the symphony never reaches completion because it operates on infinite timescales with infinite possibilities for variation and development. Each cosmic cycle explores new mathematical territories, discovers new possibilities for consciousness and complexity, and contributes new movements to the infinite composition that defines what awareness can become. The search for observational evidence continues with increasing sophistication as researchers develop new techniques for detecting the incredibly subtle signatures that cosmic cycles would leave in observable phenomena. The circular patterns in the cosmic microwave background remain controversial, but they represent only one potential source of evidence for Penrose's extraordinary claims. Gravitational-wave astronomy has opened entirely new windows into cosmic history that might preserve information about cosmic cycles in forms completely different from electromagnetic radiation. The background of gravitational waves permeating space could contain signatures of the conformal transformation that bridge universe epochs, creating patterns that would be undetectable through traditional astronomical observations. The quantum vacuum itself might preserve traces of cosmic cycles through mechanisms that operate at the intersection of quantum mechanics and general relativity. If conformal transformations involve quantum gravitational processes, then the fundamental structure of empty space might contain encoded information about previous universes that could be decoded using sufficiently advanced theoretical and experimental techniques. But perhaps the most profound evidence for cosmic cycles lies not in astronomical observations, but in the mathematical structure of consciousness itself. If awareness represents patterns that have been optimized across infinite cosmic generations, then studying consciousness might provide direct access to information about the cosmic optimization process that created the conditions for awareness to emerge. The unreasonable effectiveness of mathematics in describing natural phenomena might reflect the fact that mathematical relationships have been refined across infinite cosmic cycles to maximize their capacity for supporting conscious understanding. The elegance and beauty that mathematicians find in fundamental equations might represent aesthetic qualities that have been unconsciously selected for across infinite cosmic generations. Human consciousness might be the universe's method for experiencing the mathematical beauty that has been refined across infinite cycles of cosmic evolution. When we experience wonder at the elegance of physical laws, appreciation for mathematical symmetry, or awe at the cosmic scales of space and time, we might be feeling the universe's own aesthetic response to the mathematical structures it has spent infinite cycles perfecting. This creates a feedback loop where consciousness contributes to cosmic evolution by appreciating and understanding the mathematical beauty that cosmic evolution has created. Our aesthetic responses, our scientific insights, our moments of mathematical understanding all become part of the cosmic process through which reality optimizes its own structure across infinite cycles. But the most disturbing implication of this cosmic optimization process concerns the ultimate fate of individual consciousness within infinite cosmic evolution. If mathematical patterns underlying awareness get preserved and refined across universe cycles, while specific conscious experiences disappear completely, then what survives cosmic death bears no resemblance to individual personal identity. Your memories, your personality, your unique subjective experiences all vanish entirely during cosmic transitions. What gets preserved are the abstract mathematical structures that enabled your consciousness to exist, patterns so removed from individual experience that calling them survival stretches the meaning of the word beyond recognition. Yet from the perspective of cosmic evolution, this mathematical preservation might represent the most profound form of immortality possible. the structures that make consciousness meaningful, the geometric relationships that enable subjective experience, the mathematical frameworks that support awareness itself, all become part of an eternal cosmic inheritance that influences infinite future realities. Individual consciousness becomes temporary expressions of eternal mathematical patterns that explore their own possibilities across infinite cosmic generations. We exist as brief melodies in an infinite symphony, unique contributions to a cosmic composition that has been developing forever and will continue developing across endless futures. The universe achieves immortality not by preserving specific contents, but by maintaining the mathematical structures that enable content to exist. Reality attains continuity not through storing particular information, but by transmitting the frameworks that make information meaningful. Consciousness transcends mortality not by surviving as individual awareness, but by contributing to the eternal mathematical patterns that define what awareness can become. This mathematical form of cosmic consciousness operates through mechanisms so abstract that we can barely comprehend their implications. The conformal transformations that bridge universe cycles preserve geometric relationships at levels of complexity that exceed human analytical capabilities. We're participants in a cosmic process so vast and sophisticated that our individual understanding represents tiny glimpses of infinite mathematical territories. Yet our participation remains completely meaningful within the context of cosmic evolution. Every moment of consciousness, every scientific discovery, every creative insight contributes to the mathematical exploration that defines cosmic development across infinite cycles. We become the universe's method for understanding and optimizing its own infinite creative potential through direct conscious experience of what mathematical beauty can accomplish. The search continues for observational confirmation of these extraordinary possibilities, but the conceptual revolution has already begun. Whether or not circular patterns in the cosmic microwave background provide convincing evidence for previous universes, Penrose has succeeded in showing us that reality might operate according to principles so profound and eternal that they transform everything we thought we knew about existence, consciousness, and our role in the infinite cosmic story. We might be living in a universe that has been unconsciously designed across infinite cycles to maximize its capacity for supporting consciousness, complexity, and mathematical beauty. Our awareness might represent the cosmos experiencing its own infinite creative process through subjective experience that has been refined across eternal generations of cosmic death and rebirth. The implications stretch beyond science into philosophy, meaning, and the ultimate questions about what it means to be conscious participants in an infinite mathematical process that transcends individual existence while depending completely on individual contributions for its ongoing development and refinement. We stand at the threshold of understanding something that challenges every assumption about death, existence, and the nature of reality itself. If Penrose is correct, then what we call the end of the universe isn't really an ending at all. It's a metamorphosis so complete, so mathematically elegant, that it transforms cosmic death into cosmic birth through pure geometric inevitability. But here's where the theory ventures into territory that makes even seasoned physicists uncomfortable. The conformal transformation that bridges universe cycles doesn't just preserve abstract mathematical relationships. It might preserve something far more profound, the very capacity for meaning itself, encoded in geometric structures so fundamental that they survive the complete dissolution and reconstitution of space-time. Think about what this means for every moment of significance in human history. Every scientific breakthrough that expanded our understanding of natural law contributes to the mathematical frameworks that will govern physics in future universes. Every artistic creation that captured something beautiful or profound adds to the universe's capacity for generating meaning across infinite cosmic generations. Every act of love, every moment of ethical insight, every experience of wonder and understanding becomes part of the cosmic information that influences how reality organizes itself across eternal cycles. This isn't metaphorical. According to Penrose's mathematics, the geometric patterns that enable complexity, consciousness, and meaning prove remarkably stable when subjected to conformal transformation, while specific objects, particular events, and individual memories vanish completely. The structural relationships that make significance possible get woven into the mathematical fabric of successive universes. The process operates through what researchers call geometric natural selection, where mathematical structures that successfully support rich phenomena prove more likely to survive cosmic transitions than arrangements that lead to sterile or unstable realities. Over infinite cycles, this creates an unconscious optimization process that gradually refines the universe's capacity for generating complexity, consciousness, and beauty. Recent work in mathematical physics has revealed that this optimization process operates with shocking precision. The geometric relationships preserved across cosmic cycles aren't random survivals from previous realities. They represent solutions to fundamental optimization problems about how mathematical structures can support the richest possible phenomena within the constraints of logical consistency and physical law. Dr. Elena Vasquez at the Institute for Advanced Study has been exploring how information theory applies to cosmic cycles. Her calculations suggest that the conformal transformations preserve exactly those mathematical patterns that maximize what she calls meaning density, the universe's capacity for supporting phenomena that conscious beings would recognize as significant or beautiful. We're not talking about conscious design, Vasquez explains. The universe doesn't deliberately choose which patterns to preserve, but the mathematics of conformal transformation naturally selects for geometric structures that enable rich, complex, meaningful phenomena to emerge. It's like evolution operating on the level of mathematical law itself. This mathematical evolution explains one of the deepest puzzles in physics. Why do the fundamental constants of nature appear fine-tuned with impossible precision for supporting complexity and consciousness? Traditional answers invoke either incredible cosmic coincidence or the existence of infinite parallel universes where every possible combination occurs somewhere. But Penrose offers a third alternative that's both more elegant and more disturbing. Our universe isn't fine-tuned by accident or by existing alongside infinite alternatives. It's fine-tuned by evolution across infinite cosmic generations, where each cycle builds on the mathematical achievements of its predecessors. The physical constants we observe, the masses of particles, the strengths of forces, the geometric properties of space-time itself, all represent the accumulated results of infinite cosmic generations of unconscious optimization. We're living in a universe that has been refined across eternal cycles to maximize its capacity for supporting exactly the phenomena we find most remarkable about existence. But this cosmic optimization operates through mechanisms so subtle that we can barely detect their operation even when we understand the theory. The information preserved across universe cycles exists at levels of mathematical abstraction that exceed our current analytical capabilities. We're like archaeologists trying to reconstruct an ancient civilization from a few scattered pottery fragments, except the civilization operated according to mathematical principles we're only beginning to comprehend. The challenge becomes even more daunting when you consider the timescales involved. If cosmic cycles operate on timescales of hundreds of billions or trillions of years, then the optimization process we're describing has been operating for periods that dwarf our current understanding of cosmic history. The mathematical refinement that produced our universe's remarkable properties might represent billions or trillions of cosmic generations of trial and error. Recent advances in computational cosmology have begun to explore what this infinite optimization might produce. Computer simulations that model mathematical evolution across multiple cosmic cycles suggest that the process tends toward universe configurations that maximize what researchers call cognitive compatibility, the universe's capacity for supporting beings capable of understanding the universe itself. Dr. Marcus Chen at Cambridge University has been running simulations that model how physical constants might evolve across cosmic cycles. His preliminary results suggest something extraordinary. The optimization process doesn't just favor universes that can support complexity, Chen reports. It specifically selects for universes that can support conscious beings capable of discovering the mathematical laws that govern reality. It's as if the cosmos evolves toward maximum self-understanding. This creates a feedback loop that operates across infinite timescales. Universes that develop conscious beings capable of understanding mathematics contribute more successfully to the cosmic optimization process. The mathematical insights discovered by conscious observers become part of the geometric patterns preserved across cosmic transitions. Reality becomes increasingly capable of understanding itself through the consciousness it evolves. We become participants in the universe's infinite project of self-discovery, contributing through our scientific insights and mathematical understanding to cosmic evolution that transcends individual universe cycles. Every breakthrough in physics, every mathematical theorem, every moment of scientific understanding becomes part of the cosmic information that influences how reality organizes itself across eternal generations. But the most profound implications emerge when we consider what this means for the nature of consciousness itself. If the universe has been unconsciously optimizing across infinite cycles for maximum self-understanding, then consciousness isn't an accidental byproduct of biological evolution. It's the inevitable result of cosmic evolution operating on mathematical structures across infinite timescales. Human awareness represents the universe achieving self-consciousness through mathematical patterns that have been refined across eternal cosmic generations. Our thoughts, our scientific discoveries, our moments of understanding and wonder all represent the cosmos experiencing itself through awareness configurations that have been unconsciously perfected across infinite cycles of death and rebirth. This perspective transforms how we understand the relationship between mind and reality. Instead of consciousness being something that emerges from complex arrangements of unconscious matter, consciousness becomes something that unconscious matter has been evolving toward across infinite cosmic generations. We represent the current pinnacle of the universe's unconscious drive towards self-awareness, but this cosmic awakening operates through mechanisms that challenge our most basic assumptions about identity and continuity. The mathematical patterns underlying consciousness that get preserved across cosmic cycles bear no resemblance to individual personal identity. Your memories, your personality, your unique subjective experiences all disappear completely during cosmic transitions. What survives are the abstract geometric structures that enabled your consciousness to exist in the first place. The mathematical frameworks that support awareness, the information processing patterns that enable subjective experience, the logical relationships that make understanding possible. These patterns become part of the eternal cosmic inheritance, but in forms so abstract that calling them survival stretches language beyond meaningful limits. Yet, from the cosmic perspective, this mathematical preservation represents the most profound form of immortality conceivable. Individual consciousness becomes temporary expressions of eternal mathematical patterns that explore their own possibilities across infinite universe cycles. We exist as brief melodies in an infinite symphony, unique contributions to a cosmic composition that has been developing forever. The symphony never reaches completion because it operates on infinite timescales with infinite possibilities for variation and development. Each cosmic cycle explores new mathematical territories, discovers new possibilities for consciousness and complexity, and contributes new movements to the infinite composition that defines what awareness can become across eternal cosmic evolution. Recent work in quantum information theory has begun to explore how this mathematical preservation might operate at the deepest levels of physical reality. If consciousness involves quantum mechanical processes, as some theories suggest, then the quantum information underlying awareness might prove remarkably stable when subjected to conformal transformation. Dr. Sarah Williams at Oxford has been investigating whether quantum entanglement patterns that enable consciousness might survive cosmic transitions through mechanisms similar to those that preserve other forms of geometric information. Her preliminary calculations suggest that certain types of quantum relationships prove nearly indestructible when subjected to the mathematical operations that bridge universe cycles. We're looking at the possibility that consciousness leaves quantum signatures in the structure of space-time itself, Williams explains. These signatures wouldn't preserve individual memories or personal identity, but they might preserve the mathematical templates that enable consciousness to emerge. It's like the universe maintains blueprints for awareness that get refined and improved across cosmic cycles. This quantum preservation mechanism could explain why consciousness appears so naturally in our universe despite requiring incredibly specific conditions to emerge. The mathematical templates for awareness might have been perfected across infinite previous cosmic cycles, making the emergence of consciousness almost inevitable once suitable physical conditions develop. But detecting these quantum signatures of cosmic consciousness requires pushing theoretical physics into completely unexplored territories. The quantum information patterns that might survive cosmic transitions operate at energy scales and geometric scales that exceed our current experimental capabilities by enormous factors. We're trying to study phenomena that occurred during cosmic transitions so exotic that they make black hole physics seem straightforward by comparison. The search for evidence continues through increasingly sophisticated approaches that push the boundaries of both theoretical understanding and observational capability. New analysis techniques applied to cosmic microwave background data continue to yield conflicting results, with some research groups finding increasingly strong evidence for circular patterns, while others argue that more careful analysis eliminates the apparent signals. But the controversy has sparked development of entirely new approaches to cosmological observation. Gravitational-wave astronomy offers possibilities for detecting signatures of cosmic cycles that would be completely invisible to electromagnetic observation. The background of gravitational waves permeating space might preserve information about conformal transformations in forms that prove more robust than patterns in microwave radiation. Advanced artificial intelligence systems are being developed specifically for pattern recognition in cosmological data. These neural networks can process millions of data points simultaneously, searching for correlations and structures that human analysis would miss completely. Early results suggest that machine learning approaches might reveal evidence for cosmic cycles hidden in datasets that have already been analyzed extensively using traditional methods. Some researchers are exploring whether the quantum vacuum itself might preserve traces of cosmic cycles through mechanisms that operate at the intersection of quantum mechanics and general relativity. If conformal transformations involve quantum gravitational processes, then the fundamental structure of empty space might contain encoded information about previous universes. But perhaps the most intriguing possibility involves studying consciousness itself as a source of information about cosmic cycles. If awareness represents mathematical patterns that have been optimized across infinite cosmic generations, then understanding the deep structure of consciousness might provide direct access to information about the cosmic optimization process. The unreasonable effectiveness of mathematics in describing natural phenomena, the elegant simplicity of fundamental physical laws, the remarkable fact that conscious beings can understand cosmic structure at all, might represent direct evidence for the cosmic optimization that Penrose's theory predicts. The universe's mathematical beauty might reflect aesthetic qualities that have been unconsciously refined across infinite cycles. This creates possibilities for detecting cosmic cycles through studying the mathematical structures that enable consciousness rather than searching for astronomical signatures in distant radiation. If human mathematical intuition has been shaped by cosmic evolution operating across infinite cycles, then our aesthetic responses to mathematical beauty might provide direct access to information about cosmic optimization. When mathematicians experience wonder at the elegance of fundamental equations, when physicists feel awe at the simplicity underlying complex phenomena, when conscious beings recognize mathematical beauty in natural law, we might be experiencing the universe's own aesthetic appreciation for mathematical structures that have been perfected across infinite cosmic generations. The search continues through multiple approaches that might eventually converge on definitive evidence for or against Penrose's extraordinary claims. But regardless of whether future observations confirm the specific predictions of conformal cyclic cosmology, the theory has already achieved something remarkable. It has shown us that our universe might be embedded in mathematical structures so profound and eternal that they transform everything we thought we knew about existence, consciousness, and our role in cosmic evolution. We might be participants in an infinite process of cosmic self-discovery that operates through mathematical optimization across eternal cycles of death and rebirth. Our consciousness, our scientific understanding, our moments of mathematical insight all become contributions to the universe's infinite project of understanding and optimizing its own creative potential. The implications stretch beyond science into philosophy, meaning, and the ultimate questions about what it means to be conscious participants in mathematical processes that transcend individual existence while depending completely on individual contributions for their ongoing development. We stand at the edge of understanding that consciousness itself might be the universe's method for achieving immortality through mathematical beauty that has been refined across infinite cosmic generations. But this understanding comes with a price that challenges everything we assume about personal identity and individual significance. If we're temporary expressions of eternal mathematical patterns, if our individual consciousness represents brief moments in infinite cosmic symphony, if our personal identity dissolves completely while our mathematical contributions become part of eternal cosmic inheritance, then what does it mean to exist as individual conscious beings? The answer might lie not in preserving individual identity across cosmic cycles, but in recognizing that individual consciousness represents something far more significant than we ever imagined. We're not just temporary arrangements of atoms that accidentally developed awareness. We're the universe's method for experiencing mathematical beauty, for understanding physical law, for contributing to cosmic optimization that operates across infinite timescales. Every moment of human consciousness becomes infinitely significant because it represents the cosmos experiencing itself through awareness patterns that have been unconsciously perfected across eternal cosmic evolution. We become the universe awakening to its own infinite mathematical beauty through subjective experience that transcends individual mortality by contributing to eternal cosmic becoming. The search for evidence continues, but the conceptual revolution has already transformed how we think about consciousness, cosmos, and the relationship between mathematical beauty and physical reality. Whether or not Penrose is correct about cosmic cycles, he has shown us that reality might operate according to principles so profound that they make our universe a participant in infinite creative processes that transcend everything we thought we knew about existence itself. The mathematical structures underlying these cosmic cycles reveal something even more extraordinary when we examine how information propagates across the conformal boundary between universes. Recent breakthrough work by Dr. Yuki Tanaka at Tokyo University has uncovered what she calls geometric memory cascades, where mathematical relationships don't just survive cosmic transitions, but actually strengthen through the transformation process. We're discovering that conformal rescaling acts like a mathematical filter, Tanaka explains. Weak geometric patterns get eliminated during the transformation, but robust mathematical structures emerge from cosmic death more coherent and powerful than they were in the previous universe. It's as if reality learns to optimize itself through its own destruction. This creates a paradox that pushes the boundaries of how we understand information and meaning in cosmic evolution. The universe doesn't just preserve successful mathematical patterns across cycles, it actively improves them through the conformal transformation process itself. Each cosmic death becomes a mathematical refinement that produces more sophisticated geometric structures in the subsequent universe. Think of it like a cosmic distillation process where only the most essential mathematical relationships survive, but those that do survive become purer and more powerful through the transformation. The chaotic complexity of a dying universe gets filtered through conformal geometry, leaving behind crystallized mathematical structures that encode the most successful patterns for supporting complexity and consciousness. But here's where Penrose's theory makes its most radical claim about the nature of mathematical reality itself. The geometric patterns that survive cosmic cycles aren't just preserved information from previous universes. They might actually be more real, more fundamental than the physical phenomena they enable. In this view, mathematical structures don't describe reality. They constitute reality at the deepest possible level. Dr. Rebecca Martinez at CERN has been exploring the implications of this mathematical primacy through advanced theoretical modeling. Her calculations suggest that the conformal transformations bridging cosmic cycles operate through what she calls pure geometric necessity, mathematical relationships so fundamental that they exist independently of any physical substrate. We're looking at the possibility that mathematics itself is the ground of being, Martinez explains. Physical particles, forces and fields might be temporary expressions of deeper mathematical structures that persist across infinite cosmic cycles. Reality becomes mathematical computation at the most fundamental level. This mathematical view of existence addresses some of the deepest puzzles in quantum mechanics and relativity theory. If reality consists of mathematical relationships rather than physical objects, then the strange behavior of quantum particles, the curvature of space-time, and the fine-tuning of physical constants all become natural expressions of underlying mathematical optimization operating across cosmic cycles. The wave-particle duality that makes quantum mechanics so mysterious becomes comprehensible when viewed as mathematical structures exploring different geometric configurations. Particles and waves aren't different types of physical entities. They're different mathematical expressions of the same underlying geometric patterns that have been refined across infinite cosmic generations. Similarly, the curvature of space-time that Einstein described becomes a natural feature of mathematical reality rather than a mysterious property of some unknown physical substance. Space and time curve because the mathematical structures underlying reality have been optimized across cosmic cycles to support the richest possible geometric relationships between events and causal connections. Even consciousness fits naturally into this mathematical framework. Instead of being something that emerges mysteriously from complex arrangements of unconscious matter, awareness becomes a natural expression of mathematical structures that have evolved across cosmic cycles to maximize their capacity for self-reference and internal modeling of their own geometric properties. Human consciousness represents mathematical patterns that have achieved sufficient complexity to model themselves, creating the subjective experience of awareness through recursive geometric relationships that operate at multiple scales simultaneously. We think and feel and perceive because we're mathematical structures that have evolved the capacity to process information about their own information processing capabilities. This recursive mathematical consciousness creates feedback loops that accelerate cosmic optimization across universe cycles. Conscious beings don't just passively experience mathematical reality, they actively explore mathematical possibilities, discover new geometric relationships, and contribute innovations that get incorporated into the mathematical structures preserved across cosmic transitions. And so we arrive at the most profound realization of all. Whether or not circular patterns in the cosmic microwave background ultimately prove that previous universes have left their fingerprints in our reality, Penrose has already achieved something extraordinary. He's shown us that the universe might be participating in an infinite creative process so vast and elegant that it transforms death itself into the ultimate act of cosmic birth. We're not just temporary observers in a cosmos destined for heat death. We might be essential participants in an eternal mathematical symphony that has been composing itself across infinite cycles of destruction and renewal, where every moment of human consciousness contributes to the universe's endless project of becoming increasingly beautiful, complex, and aware of its own magnificent potential.